Hey guys, it's Miss Johnson, and I'm here to bring you our notes for the last part of section 12.3, which is the last section of your book. Yep, this is the last video of new content that we have for this whole course. So congratulations, you made it to the end. Here we go. So we've been talking about inference for slope in section 12.3. We talked about what are the conditions. We talked about what that slope looks like, the sampling distribution of the slope, the linear regression line, the residuals, all that stuff. We looked at the conditions. Then we talked about calculating a confidence interval, a CI, for that slope. Today we are going to actually perform a significance test for that slope. So good news for us, conditions are the same. Framework of how we nail down that significance test is the same, doing state, plan, do, conclude. All of that stuff is going to look really familiar. So here we go. We're jumping right in. So here is our significance test for slope. So the standardized test statistic is going to be the statistic minus the parameter divided by the standard deviation. Now we all know that if we're not able to look at the population, which is true in most cases here, then we have to look at the sample. So it says, suppose the conditions are met to perform a test of the hypothesis. Null is that the beta is the hypothesized slope. You have to find your t-value, your test statistic, meaning the sample slope minus the hypothesized slope divided by the standard error. So find the p-value by calculating the probability of the t using degree of freedom n-2 to give reference to your alternative. All right, so here's our example for today. We're going to do one of these top to bottom. Here we go. It says infants who cry easily may be more easily stimulated than others. This may be a sign of higher IQ. Child development researchers explored the relationship between the crying of infants 4 to 10 days old and their later IQ test scores. A snap of the rubber band on the sole of the foot caused the infants to cry. The researcher recorded the crying and measured its intensity by the number of peaks in the most active 20 seconds. They later measured the children's IQ at age 3 using the Stanford Binet IQ test. The table contains the data from a random sample of 38 infants. Okay, so you've got the cry count and you've got the IQ. So they performed an action, snapping a rubber band on a baby's foot, which is interesting, but whatever. Nonetheless, they performed an action to make a baby cry, and then they tested their IQ later. Here is all of the data. Remember, I talked about if you're doing inference for slope, you're going to be probably, most likely, given these three things. You're also going to be given the computer output of the data. So here's the computer output from the least squares regression analysis of these data. Do these data provide convincing evidence? Here's your question. At the alpha 0.05 level of a positive linear relationship between count of crying peaks and IQ in the population of infants. Okay, so there's your scatter plot. Okay, you've got the LSRL going through the middle. There's the residual plot. Here's your resid of 0, which is an important thing to know. And then here is your histogram of the residuals, which you kind of want to see to have a normal pattern like that. Okay, great. So now let's go through and actually do our example. So state, our first step is to state. We're going to state the hypotheses. So the null is that the slope is 0. The alternative is that the slope is greater than 0. Okay, the question was, do we have convincing evidence that there's a positive linear relationship? If it's a positive linear relationship, slope is greater than 0. Okay, great. Name your parameter, where beta is, you can write equals or is, the slope of the regression line. Relating y equaling IQ scores to x equaling count of crying peaks in the population of infants. We will use, name your alpha level, alpha 0.05. Okay. So you've got null, you've got alternative, you've got parameter, you've got alpha level. Great. Okay, plan. Here come all of our crazy conditions here. So now this isn't a t-interval like we did before. This is a t-test for the slope. Yesterday in our last lesson, we did a t-interval. Now we're going to do a t-test. We still have all the conditions. So L, talking about whether the data looks linear or not. So the scatter plot shows a linear relationship. Between crying peaks and IQ and the residual plot shows no curve pattern. Shows no curved pattern. Okay. Hopefully I can fit my other ones on here. This is not a big box and there's a lot of conditions here. So independent, this is a sample, so I need to address the 10%. 38 is less than 10% of all infants. Truth. Okay, then we get into N, normal. The histogram of the residuals does not show a skew or outliers. Or outliers. Okay, so that's N. How about the equal standard deviation? So we're going to go back to that residual plot. The residual plot shows a fairly equal amount of scatter around the 0. Remember they said don't get too hung up on the residual plot and the scatter plot, any of these. Don't get too hung up on these being a perfect picture. This is sampling distribution, so we expect some variability. So the residual plot shows a fairly equal amount of scatter about the resid equals 0 line for all x values. Okay, and then the last one, random assignment. This is a random sample of 38 infants. All right, there's our conditions. Holy buckets, those take a while. Here we go. So now let's talk about the do statement. So for do, we need several things. We need, what is our t value? So the t value comes from your computer output. This is where you can use that t value. So the t value for the cry count, again, this x variable, this is basically the line that you want to look at. The only time that you come up to this top line really is to get that y-intercept. But the rest of it comes from this x count. That's your slope. That's the standard error. That's now the t value for testing. So the t value is 3.07. And then you can go in and do TCDF to get the p value. So in your calculator, you would do second and distribution. So second distribution, and look for TCDF, and then you've got your parameters there, or you've got your, your values. So the lower limit is 3 3.07 up to positive infinity. Degrees of freedom is that 38 minus 2, which is 36. Okay, that's probably another thing that I'd list here is the degrees of freedom. So your degrees of freedom is 38 minus 2 equaling 36. And then you get into the p-value. So your p-value, here's where you could use the computer output for the p-value as well. Now, take a look at your computer output. Your computer output says a p-value is 0.004. This is both tails. Okay, you are looking at the alternative of beta being greater than 0. So you need to take this 0.004 and you need to cut it in half. Now, if you did TCDF on your calculator, you would see that you got a result of 0.002. That is that 0.004 cut in half. So your p-value is 0.004 divided by 2, which is 0.002. Okay, so again, we cut that in half because we're only looking at a one-sided test for this alternative. HA is one-sided. Okay, so this p-value gives you both tails. You don't want both tails. You want one tail. Okay, now let's talk about the conclude statement. So in conclude, I'm going to conclude that. Because the p-value of 0.002 is less than alpha equaling 0.05, we reject the null. There is convincing evidence of a positive linear relationship between the count of crying peaks and IQ score in the population of infants. All right, state plan do conclude, and we found convincing evidence. Here we go. Like everything else, we have options to put all this into our calculator. Now, you were given the data in the very initial question, so you could type the data into X1 and Y1, and then you can go into that LinReg test. So LinReg comes from stat, and then over to tests, and then it's the very last one. Go down to that LinReg t-test. LinReg t-test. You'll get the t value, you'll get the p value, they'll tell you the degrees of freedom, you'll get the y-intercept, and you'll get the slope. And then you can even keep going. You're going to get the standard deviation and the standard error and stuff down there. So option to do it on your calculator, always a bonus, so that's great. All right, believe it or not, this takes us to the end. You made it. This is the end of your very last video in our video series for AP Stats. So congratulations. Thanks for tuning in, and I'll catch you next time.